Okay, today in class we learned how to simplify radicals and how to apply the Pythagorean theorem. So we'll simplify radicals, we'll multiply them, and then we'll use the Pythagorean theorem to find the missing side of a triangle. So a square root for any real number a and b, if b squared equals a, then b is the square root of a. So we talked about if b squared equals a, then to solve for b, we do the opposite of squaring, which is a square root. So b equals the square root of a. And that's where that comes from. We did some of these in our problems of the day where we said x squared equals 36. What is x? To find x, we take the square root. Now, today we're going to learn how to take the square root of something that isn't a perfect square. 36 is a perfect square. So, for example, of 52, we would take the square root of that, and then I'm going to show you how to simplify this radical. Okay, so perfect squares are 4, 9, 16, 25. We talked about that this is 2 times 2, 9 is 3 times 3, 16 is 4 times 4, 25 is 5 times 5, so we would get an idea of what a perfect square is. A perfect square is when you multiply two numbers that are the same value to get that number. Simplifying radicals, we look for perfect squares. If there aren't perfect squares, then, so it says here, if the number is not a perfect square, try to break it down, which is factoring, to prime numbers and perfect squares. So prime numbers we talked about are numbers that can be factored to itself and 1. So for example, 5 can be factored to 5 and 1. 3 can be factored to 3 and 1. So both of those are prime. 7 is a prime number, 1 is a prime number, 2 is a prime number. We said that 9 is not because it breaks down to 3 times 3. So it has to be itself and 1 to be a prime number. Those are the only two numbers that will give you that number. So here we're going to simplify the radical. There are multiple ways to break this down. And we talked a lot about what the index is. The index is that number. If there isn't a number, it's a 2. And what that means is that we've got to have 2 of the same number to bring one outside of the radical. So 50 can be broken down to 25 and 2. There are two ways to look at this. 25 is a perfect square, and we know that the square root of 25 is 5. Or you can continue breaking this down to prime numbers. 25 is 5 times 5, and then times this 2. And then we can say it needs 2 of the same number to bring one out. So we have 2 5s, so we get to bring one out, and there's a 2 left inside. Now, you could have gotten that answer by saying, oh, 25 is a perfect square. The square root of 25 is 5, and that 2 right here stays inside the radical. Either way you get to it, I don't care. So for the next one, 45 breaks down to 9 and 5. Right here you can say 9 is a perfect square, or you can break 9 down to 3 and 3. And we're looking for 2 of the same number to bring one out. And that 5 stays because there's only one of them. Okay, 98. This breaks down to 2 times 49. Now right here you could say, oh, the square root of 49 is 7, and come up with our answer, 7 root 2. Or you could break this down to 7 and 7. And there are 2 7s, so we can bring one out. And that 2 has to stay inside the radical. Multiplying radicals, I say here multiply the inside, multiply the outside. What I mean by that, multiply the numbers on the outside. There aren't any numbers on the outside, so we don't have to do that part. And then multiply the numbers on the inside with a little bit of a hesitation. We're going to go ahead, because these both have an index of 2, we can multiply the 5 and the 15, but eventually we want to break this down, so I'm going to actually break 15 down to be 5 and 3, and then you can see that we have 2 5s, so 1 5 will come out, and the 3 will stay inside the radical. On B, we have these two numbers that we're going to multiply that are both outside, so 2 times negative 6 is negative 12. And then inside the radical we have a 7 from the first one, the second one's a 14. We want to break that down to 7 times 2, and we see that we have 2 7s, so we're going to bring them out. When we bring it out, we multiply. And then your last step would be to multiply negative 12 and 7 to get negative 4 with that root 2 at the end. On C, there's several ways to look at this, and I looked at it as a power. With the power, remember, we have to distribute this to both terms. So we get 3 squared and a root 6 squared. Now this 3 squared becomes a 9, and this root 6, anytime you have a square root and a squared, those are opposite operations, so they'll cancel each other and you get a 6 left. Another way to look at that is to say that we have a 6 times a 6 because there are 2 of them, so it takes 2 to bring 1 out. So either way you look at that, we get a 6 here, and 9 times 6 is 54. In this case, there was nothing left inside the radical, so we don't put it there. Okay, a right triangle is a triangle that has one right angle. So we got a right angle, and the other 2 angles, column A and B, these are complementary. Complementary means that they add to be 90. And we talked about if one of them is 90 and the other 2 add to be 90, then the whole triangle is 180 degrees. Okay, the hypotenuse is what's known as the longest side, and it has to occur when you have a right triangle is when you'll get a hypotenuse. And it's always opposite that right angle. It doesn't touch the right angle. The other 2 sides are called legs. So the 2 sides that form the right angle, so the 2 sides that touch this right angle, are known as legs, either A and B, and it doesn't matter how you label those. The Pythagorean theorem is a proven rule, and it describes the relationship between the lengths of the legs and the hypotenuse of any triangle. It says if a triangle is a right triangle, and that's really key. For you to be able to apply the Pythagorean theorem, it has to be a right triangle. Then, and I have a picture of a right triangle, then we get a squared plus b squared equals c squared, and we actually sang this today to a tune of We Will Rock You, and it says a squared plus b squared equals c squared to help us try to remember that. Remember, the only way that we can use this formula is if you have a right triangle. So example 3 says use the Pythagorean theorem to find the missing side. What you want to notice first is what side you are missing. Here we're missing this side right here, and this is what's known as the longest side because it's opposite, so I'm going to call it C for the hypotenuse. And then we set up our equation, 12 squared plus 9 squared, and it doesn't matter the order there, equals c squared. Okay, 12 squared is 144, plus 9 squared is 81, equals c squared. We add those, get 225. Now, it's not looking for c squared, it's looking for c, so to find c, we take the square root, we do the opposite of squaring, and we get the square root of 225 is 15. So c is 15 inches. We're going to use those same units. Okay, B is similar. We're going to identify the side we're missing. It looks like we're missing this side here, and it meets up but helps form the right angle, so it's either A or B. We're going to call it B, and then we'll set up our equation. 8 squared plus b squared equals 24 squared. 8 squared is 64. 24 squared is 576. Then we're going to subtract the 64 over to get b alone. So we get 512. And then from here we're going to take the square root. Now, because 512 is not a perfect square, we're going to go ahead and break it down like we did before. So this is the same as 2 times 256. And I know that 256 is a perfect square, so I'm going to say the square root of 256 is 16, and the 2 will stay inside the radical. And that would be meters. And if you're not sure, you'll just have to keep breaking 256 down until you find either 2 of something or until you have prime numbers. Your converse, this reverses the order of a theorem. So we talked about I used the statement, if I go to the store, then I buy apples. That would be the original statement. If I took the converse of it, I would say, if I buy apples, then I go to the store. And that's what it means by reversing the order. So we're going to look at the converse of the Pythagorean theorem. It says if the sides A, B, and C make a triangle such that a squared plus b squared equals c squared, then it is a right triangle. So we're going to first say, hey, if the sides equal a squared plus b squared equals c squared, then we get a right triangle. And I'll illustrate that here. This is the original theorem. It says if a triangle is a right triangle, then a squared plus b squared equals c squared. The converse simply states if a squared plus b squared equals c squared, then the triangle is a right triangle. So you can see that we switch those. And that's what converse does, is it reverses the order. So on example 4, we're going to determine whether each triangle with sides of given lengths is a right triangle. I'm actually going to add to this. We're going to first determine with the 3 lengths if we get a triangle. And we talked about if I gave you 3 sides and they were like this, then there's no way that we could actually form a triangle. This side is much too long for us to actually connect the other 2 sides. So you want to make sure that the 3 lengths given actually will give a triangle. So to do that, all we have to do is take 2 sides, add them together, and make sure they're greater than the 3rd side. So 4 plus 5 is 9. 9 is greater than 7. We're going to do that with all 3 sides. 5 plus 7, is this bigger than 4? Yes. And then the last 2 sides. 4 plus 7, is this greater than 5? Yes. So we know that it is a triangle. Then we're going to decide if it's a right triangle. To decide if it's a right triangle, we're going to assume that these are the 3 lengths of the triangle, and the 7 is the hypotenuse because it's the biggest length. So we'll do our a squared plus b squared equals c squared, starting with 4 squared plus 5 squared equals 7 squared. 4 squared is 16 plus 5 squared is 25 equals 7 squared, 49. We add these 2 to get 41, and we see that it is not equal to 49. So it is not a right triangle. Okay, again, we want to make sure that we actually have side lengths that can form a triangle. So we take 36 plus 48, and that is greater than 60. We take 48 plus 60, is that bigger than 36? Yeah, that's pretty obvious. And then we need to take 36 and 60, is that bigger than 48? Yes. So yes, it's it's a triangle. From there, we'll apply our Pythagorean theorem. And again, notice that this is our longest value, the 60, so we're going to say that's our hypotenuse. So we'll take 36 squared, we'll add 48 squared and see if it's equal to 60 squared. Well, 60 squared is 3600. 36 squared is 1296. And 48 squared is 2304. We combine those and add them, and we get 3600 is equal to 3600. So yes, it is a right triangle. And we just use the converse to prove that it is a right triangle. Okay, good luck with your assignment. It's the Simplifying Radicals and Pythagorean Theorem worksheet.